This lesson introduces you to the typical equipment found in an X-ray room and basic radiation safety. Many of the topics are covered in greater detail in later lessons.
The essential X-ray room features include the same basic components. Most include the following features: an X-ray tube, tube support, a wall and table-mounted cassette holder, a transformer cabinet, a work counter area that holds the control booth with the control console. To protect the X-ray operator from scatter radiation, the control booth is separated by a lead barrier from the X-ray room. This lead barrier is a large lead glass window so the X-ray operator can see the patient. The control console, located in the control booth, sets the exposure factors and starts the exposure. The transformer is an essential part of the X-ray machine as it produces both the high voltage required to produce X-rays and the low milliamperage, MA, needed for the X-ray tube.
Detents and the collimator are parts of the X-ray machine that assist the operator in positioning the X-ray tube in place. Detents are mechanisms built into the tube support that stop movement at a particular point, locking it to the desired location. The collimator is attached under the tube housing, indicating the beam size, location, and the field center. It allows the size of the radiation field to be adjusted. There is a light that helps with the alignment of the central ray. Controls on the front of the collimator allow adjustment of the size of each dimension of the radiation field.
As X-rays leave the X-ray tube, they form a triangular-shaped X-ray beam. An imaginary line in the center of the X-ray beam and perpendicular to the long axis of the X-ray tube is called the central ray or the CR. The CR is critical in positioning the patient because the point is used to align the X-ray tube to the body part to be imaged. A light is shined on the body part with a black crosshair that identifies the exact center of the X-ray beam.
The radiation that leaves the tube is called primary radiation. Radiation from the primary beam is randomly scattered within or outside the body. Scatter radiation travels in all directions from the patient, is very difficult to control, and has less energy than the primary beam. Remnant radiation is what remains of the primary beam after it has been attenuated or reduced in intensity by the patient's body.
Remember, there is 3 types of radiation. Primary, the X-ray beam that leaves the tube and is unattenuated. Scatter, which is radiation occurs after contact with any mass. Scatter radiation travels in all directions within and outside the body and is difficult to control. Also remnant radiation or exit radiation that remains from the primary beam after it has been passed through matter or the body. The pattern of the remnant radiation creates the X-ray image.
IR system or image receptor consists of a cassette that contains a phosphor imaging plate that stores the image until it is processed for viewing. Once the X-ray beam is captured and stored, the information is sent to the control booth for processing by the BMO.
Applying radiation safety measures is vital to X-ray operators as they are in daily contact with X-ray exposure. This topic will be covered later in the course. Here are specific practices that you should follow every time an exposure is taken. Ensure that you and anyone in the control booth are entirely behind the lead barrier. Non-essential people should not be in the X-ray room. And remove any image receptors except the one in use.
Make sure the X-ray room door is fully closed while in use. Double-check all the settings and patient positioning before taking images. Only take X-rays on the intended body part using the collimator.
Thank you for watching Chapter 2's lesson.
Remember, X-ray rooms have specific equipment that each serve purposes. Once you understand what each one does, the better you will be at performing X-rays.